Yeah, so show you the topics I'll be going over. Yeah, so these are the main topics I'll be going over today. So first I'll give a short intro to what so first I co-founded Torch Labs. We mainly sell digital goods online. And I also work full-time as a software engineer for AI and machine learning startup company. Over there, we both places we use Node, and so based on that, I'll try and go over how it's used in industrial applications and also a quick introduction to the language. Yeah, so we are software as a service company. We sell mainly B2B, so business to business, meaning we have clients. So each client has their own customers. So we have about 3 services now. Going over one of them, which is our dashboard service, where our clients can basically buy a full dashboard from us and start selling to their own customers. So this type of architecture is called a tenant architecture, where each tenant has their own data and needs to be isolated for each person. And there's a lot of things where you have to isolate. You have to make sure that data between your tenants are not being shared amongst each other. And yeah, that's a short intro to Torch Labs. So now let me go over what Node.js is. So the history of it is it was created in 2009 by Ryan Dahl. Before 2009, JavaScript existed, but it was only on the browser. So all JavaScript developers were mainly web developers, meaning they would program this only for the to be used on the browser. So on the browser, the way the code runs is each browser has their own JavaScript engine. Each JavaScript engine is made differently, but they all have to support the same features. So you have to be able to program in one way, and all the browsers should support it. So what Randall did was he pulled out the actual JavaScript engine from Google Chrome, and he made it into a tool that you can run JavaScript on your own machine and make it a server-side language. So what that means is now JavaScript front-end developers who mainly worked on the browser can also write back-end applications in one language. So if you want to build a full web application, you can do it with just one language, whereas previously you had to write your client-side app or your front-end app in JavaScript and your back-end app in whatever other language. So use cases are IO intensive applications, which means applications that do a lot of input output. So like, and then real-time data streaming, IoT. So what this means is a lot of apps that interact with the database a lot, or do a lot of non-computationally heavy tasks. So yeah, coming to that, a non-use case is like math and data intensive apps, games, or like low-level programs. I'll go over why this is the case in a bit, but main reason is JavaScript is not as fast as most other languages, but it's not completely slow too. So if you want to do like a game or an app that requires a lot of data, you might be better with a language like Java or C++. Okay, so these are a few important keywords to know about Node or JavaScript as a whole. It's high level, which means it abstracts away a lot of lower level machine computer things. For example, if you use a language like C, you have to worry about memory management and how memory is handled in the CPU or in the the RAM. So JavaScript is high level, which means you don't have to worry about that. And also data types are not as big of a thing. For example, in like Java, you have to define all your data types, but in JavaScript, you don't have to. It kind of handles that for you. So it's also single threaded, which means each application, any program you run in a computer needs CPU time, which means if it needs to do anything, it needs some time from the CPU. So some languages you can multi-thread, which means, for example, like Java or C++, you can actually use multi-threading to make a lot of repetitive tasks much faster. But JavaScript is single-threaded, but there is a caveat to that. It has a mechanism called the event loop, which allows it to kind of act like it has threading. I'll explain that soon, but just for now, know that. Then it's also garbage collected, which, like I said before, since it doesn't handle its own memory, it handles its own memory. It actually cleans up any unused variables and things like that. So it's also interpreted. So some languages are compiled. For example, C or C++ and Java, they're all compiled languages, which means when you write your code, you have to compile it into machine code, and then you actually run the binary file. JavaScript is just-in-time compiled, which means you run it once and the program will start. So it's also prototype-based, which means under the hood, any variables are considered as objects, which means anything you use has methods attached to it. So while we do a demo, you'll see what I mean about that. Also, it's multi-paradigm, which means it allows the developer to choose what paradigm they want to use. They can use a paradigm is mainly functional or object-oriented. So for example, Java is only object-oriented. It's not functional at all. C++ is multi-paradigm, which means you can write functional or object-oriented programming. So JavaScript is the same. You can write functional, object-oriented, or a mix of whichever you please to do. Then it also has a concept of a non-blocking event loop. So like I said before, JavaScript is single-threaded, which means it only takes a single thread on the CPU. But this non-blocking event loop lets JavaScript actually act like it's not, like it's multi-processed. So this is the event loop system JavaScript has. So this is the V8 engine from Google Chrome that lets you run it locally on your machine. So these bindings are basically connections it has to the operating system. So for example, reading the file system, making network requests, things like that. So it basically has a system of a queue where every piece, or every function, or every piece of functionality will get added to this queue. And any things that require a long time, for example, network requests or reading the file system, they'll get actually added to this another queue. So here. So then the rest of the code that's non-blocking can keep running. And then once these things are finished, it will pull those in and then send those results. So which means if you have something that's a long-running task, it won't get blocked with the other code. Okay. So now I'll go over basic client-server architecture. So how a full stack application basically is built. So we have a concept of a client, which is a browser-based application. Usually it's written in HTML, CSS, and JavaScript, or you can use a UI framework like React, Vue, or Angular. So these are apps that you see on your web browser. So this is what most people will interact.
Technical about computers.
Then server is a backend application, usually written in any language, like Node.js, for example, Java, Ruby, C#. So usually the client will request resources from the server, and the server will respond. So each client can go on many computers. So if I go to google.com, for example, that's an example of a client is what you see. And then Google has servers in the background, in the backend, that when you type a search result, the server will give you the results, and the client will show the results in a nice way to the humans. Then also there's going to be a database in the back end. So it's either SQL or NoSQL. So SQL databases have you can add relationships between your data, which means it's good for a lot of data that has that you want to query a lot. And then you also have NoSQL, which doesn't have as much relations between the data, but they're much faster and they're much easier to use and scale. So scale meaning if you get a lot of traffic to your application, you want to that could be a case where the database can't handle that amount of traffic. So you'll have to scale it. So NoSQL is much easier to scale. So today we'll be using MongoDB. Node for the database, we'll be using MongoDB. For the backend, we'll be using Node. Just to make a simple API. So now that you have a concept of a simple client-server architecture, this is our Torch Labs architecture. So we have many different services and clients. So we have 4 backends in total. We have authentication service, which handles all authentication, which means logging in and like user management. Then we also have a product service, which handles all products. This main responsibility of the product service is we can request it for product information and it will respond to the client. Then we also have these Firebase cloud functions. These are kind of like a central API gateway that handle a lot of different use cases. Then we also have a proxy API backend. This mainly these are digital goods we sell. So this handles the process of giving people these digital goods. Oh, sorry. So then we have this administrator dashboard, which lets each of our clients do administrator tasks. For example, make coupons, user management, and a few other things. So I'll show a simple example of our dashboard. So this is part of our dashboard. So this is the administrator dashboard. People can view their transactions revenue here. They can add so the digital goods we sell is kind of like data. So they can top up data, then they have more settings here. So this is this dashboard is the back end of this is the cloud functions over here. Sorry. Okay, so now I'm going to do a quick demo of how to build application with Express and MongoDB. Okay, so I might go a bit fast here, but let me know if I'm going too fast, so I need to slow down. So first pull up my notes. Okay, so I'm going to do this on Visual Studio Code. So Visual Studio Code is a code editor that lets you write code in any sort of language. So first thing I'm going to do is I have to initialize my Node application. So for that, I have to run npm init -y. So this will start a node application, give me a package JSON. So this package JSON mainly stores my dependencies. So dependencies are external packages you might need in your application. Then I want to install a few things. So I'm going to install Express and Mongoose. So Mongoose lets us interact, gives us a library to interact with our database. And Express is the framework we're using to make this API. Then a few other dependencies. So these I'm installing as development dependencies, which means I won't be needing these when I deploy my application. Sorry, it's not copying. So npm install -d .env nodemon. So these I'm installing as development dependencies, which means I don't need these when I'm going into production or I'm deploying my app, but for locally, I need them. I need to use them. So .env lets me create a file called .env and store any secret variables I want to, and then I can pull them in my main application. And then when I deploy this, I can put some different values in here for the deployed version. And Nodemon just lets me write a server. So when I save the file, it restarts automatically. Okay, so now let's make our first file. So JavaScript or Node.js applications end with .js. So first thing I want to do is pull in Express. So I'm going to say a const Express goes require Express. So this is the way in Node.js how you can import things. So it's you assign it to a variable and say require. So now that I have this, I can call it. So I'm going to call it app. So app equals Express. So now I have this app and I can use it in the application. This is the basics of starting REST endpoint. So I'm going to say app.get slash means the base URL. And then you can give this a callback function. A callback function is telling Express to run this piece of code anytime this endpoint is hit. So for now, and we also get a request and a response object here. So request is the incoming request and response is how you want to respond to this call. So I can say response.send or .json. JSON is, I'll explain what JSON is shortly, but let's say I say message hello. Okay, so now I've defined a single endpoint that responds with this structure here. So now I have to actually start this. So I'll say app.listen. Then I can give it a port number. So I'm going to make a variable for my port and put that here. And then this takes in also a callback function, which will run when the server starts listening. So I'll say console.log. So console log is for printing things on my terminal. App listening on http://localhost port port. So the syntax I'm using here lets me include variables inside my strings. So I'm basically logging that this application is listening on this port. So now if I add a script here to start my app, I can name my script start and say nodemon index.js. So nodemon, I can also run my app like this. So this script will actually run on my terminal. So I'm just going to show you here. It starts, but if I make any changes here, I have to Control-C this and restart. So I'm using this tool called nodemon, which starts this app, and when I make changes, it'll restart. So I can run npm run start, and you can see it says app listening on localhost 8080. So I also defined this endpoint here. So if I go here, let's see what I get. I'm just going on my browser. It sends a response saying message hello. So I can change this endpoint to hello. So now it says cannot get slash because that endpoint I just changed to hello. So if I go to slash hello, I get that same message. Okay, so this is a basic endpoint. So let's remove this since we won't need this. Now let me write some code for the database. So for that, I need to import mongoose. Copy. And I also need to import mongoose from here via mongoose. Okay, so now that I have mongoose, I'll explain what this does over here. I imported mongoose, which is the library I'm using for my database, and I'm connecting to it with this URL. So this process.env means it's using environment variables set up in your computer. So for example, if you have any secret values and you don't want to hard code, if I have a thing called password, my password equals, I might not want to hard code this into my code because then if I push it to GitHub, or there's a lot of people working on this, I don't want my secret variables in my code. So I can use process.env.mypassword to store it in my local machine. So then when someone else gets the app, they won't have this variable and they'll have to set their own one. So what I did here was I set this URL as I'm going to set this URL in my .env file. So let me do that. So this URL isn't necessarily a secret, but when I deploy my app, I want this to be different, which is why I'm putting it here. This thing is not copying. Let me write it. So mongodb underscore URL equals mongodb : 127001 slash to-dos. That's correct. So now I can actually import this. I can use this here if I type require .env.load .config. Sorry. So this will actually load in this environment variable here. So okay. On open. Okay, so now I have some code to connect to my database, but I haven't started my database yet. So to start that, I have to run this first command on my terminal. So I have to run brew services. So this is on my Mac. This is how I do it. On Windows, it may be a bit different. So I'll do brew services start MongoDB. So, okay, it says started. So now if I refresh this, you should see it says connected to database. So now we have the app set up with a single endpoint and we're connected to the database. So next thing, we can start defining our endpoints. So our endpoints will be what actions do we want to take on this application. So we're building a to-do app. So this app, you can make to-dos, you can create to-dos, you can update a single to-do, or you can delete a to-do. So let's first define the first endpoint to get all the to-dos. So I already have this. So I'm going to add a comment here saying get all to-dos. So for this, I have to, so yeah, get all to-dos. Then let's do this, which is create a to-do. This will be post. So I'll explain what each of these means in a second. Then this will be app.patch. Then this will be app.delete. Update. Delete to do. Okay, so these are known as request methods. So if I go on the browser right now, and I refresh this page, you will see some network requests being made here. So if I look at these, do you see these all have request method, which is post. This one is get, and this is post. So these methods are a way to for the client to send requests and tell the server what it wants to do. So get method means I want to get something. Post method means I want to create something. Patch means I want to change an existing thing. And delete means I want to delete something. Okay, so now that we define the endpoints, let's define our database schema. So for that, I'll create a file called models. Then I'll make one called todo.js. So see if I can copy this. Okay. So this is our database schema, which means this is how our data will be stored on the database. So these are the three fields we're storing. There's name, note, and created at. Name will be the name of the to-do. Note will be a optional argument. So you can see this one is required, but this one is not required, which means it's optional if we add a note or not. And then created at is when this note was created. So we have a schema now. We can import this into our main application. So I'm going to say to-dos equals require. I have to go into models and to-do. So now in my get endpoint, I'm going to say I want to get all the to-dos. So I can say to-dos equals from the schema I imported dot find. So dot finds lets me get all the items in this schema. So first I'm going to also wrap this in try catch, which means if any errors happen, I don't want the whole application to crash. I want to send back a response of some sort. So I'm going to add this here. And in the catch, if any errors happen, I'm going to send the response. So I'm going to say response.send.json. message. I'll call this error.message. And now that I have these to-dos here, I can just send them. Another thing that's important is, previously I explained the concept of event loop. So I said how the event loop takes longer taking actions and puts them in a queue. So I can use sorry, I think I was muted. So since this is a asynchronous operation, I can use this keyword to wait for this thing to happen. So I can say response dot send to-dos. So now let's see if this works. So I'm using this application called Postman, which lets me make requests to different URLs. So I'm going to make a collection called to-dos. And under this, I will add a request. So I made a GET request endpoint, and it's right now on this URL. So I'll copy this, paste that here, and it's a simple GET request. So now if I hit send, we get an empty array here because right now we haven't made any to-dos yet. So let's work on that then. So now in this one, I want to create a to-do. So I want to take in a request and make a to-do in my database. So again, I'm going to add a try catch here. And in here, we can take in the request body, which means what data is the client going to send us. So I can say to-do data equals request.body. So now I have the data that I got sent to me. So I can say to-dos, new to-do equals to-dos dot create. So now I can send in the to-do data. So we need name, note, and created at will automatically be populated because it's defaulting to date.now. So I'll send in name is to-do data.name, and note is to-do data.note. Okay, so now I have created one. So I also have to await this because this is asynchronous. And I can say response.json new to do. And over here, I can catch any errors. So let me first give these, this has to be JSON, and let me give these a status code. So status code tells the client also what happened with this request. So 200 level status codes are good, and 500 means something happened internally in the server. That was the issue in the server, which is why I'm putting it for this one. But for this, I'm going to send a status of 400, which means bad request, which means you sent me some bad data. So again, JSON, then same message is error.message. Okay, so now that I've created a new to do, I said to make this async. Okay, then I can just send this with status 200. So now let's see if we can create a to do. So I'm going to call this create to do. This is going to be a post method. Let's copy this URL, and in this body section is where I send the data to the server. So it's going to be in JSON format. JSON has key and value. The structure of it is there's a key and each key has a value. So here we need to send in name. Let's say get groceries and note. For note, let's say go to kilos 7. So now if I send this, let's see. So one thing we had to do is actually tell Express that we're using JSON. So I have to say app.use express.json. So this will tell Express that I'm using JSON. You can also use other formats, but JSON is the most popular. So let's send this again. And you can see here we got a response from our server. So we created a new to-do with name get groceries note, and it gives us an auto-generated ID and created that. So now let me connect to my database and see if this got added. So Mongodb Compass lets me visualize my database. So if I just connect to it like this, you can see there's a table called to-dos. And if I click on this, you can see the to-do I just made showed up in my database. So now let's try the first endpoint we made where we can get all the to-dos. So if I send a request there, you can see I get back an array of to-dos. So let me make a few more. I can also not send a note if I want to. Let's see. So I got response, clean kitchen, note, I can say again, at 5 p.m. So now I made like about 3 to-dos, and if I send the request here, you can see the server sends back all of the to-dos I just created. So that's that one. So now I made endpoints to get all to-dos and create a to-do. So let's say I want to update a to-do or delete a to-do. For all of these, I actually need a reference to what to-do it is. So I need an ID for these. So let's make one to get a single. Oh no, this should be fine. So I want to update a single to-do or delete a to-do. For that, I'm going to make a helper function. So I'm going to make a middleware for this. A middleware basically lets you define a function, and you can call that function for any requests that come in before it comes into this main function body. So I'm going to name this get to do, and if you see here, this has a :/ID. So this can be accessed in the request as a query parameter. So for example, here I can say request.params.id. This ID is the same one that's here. If I change this to do ID, it will become to do ID here. So I'll keep this as ID. And since I'm doing it here, I'll name this to do ID. This should be request. And now that I have this, I can say to do equals to-dos.find by ID. And I'm sending this here. So this will find the to-do by the ID. And I have to await this. So again, I'm going to add a try catch. Actually no need the try catch here. Then I'll say if not to do. So what I'm doing here is saying if I don't find the to do, I'm going to directly send a response from here. So res.status for one status means not found, and JSON message to do not found. And then again, I'll do a try catch to catch any errors. Like this, then catch error. And then if I catch error, I will say res.status 500 .json message dot message. Okay, so I'll explain this a bit more. So here what I'm doing is I have a query parameter, which is this, and I retrieve the to-do ID from there, and I get a single to-do by using this function. It gets a single document by the ID. And if I don't find it, I'm going to say to-do not found. I'm going to immediately respond. If I do find it, I'm going to attach it to the request. This should be request. I'm going to attach it to the request object. And when I say next, it will go to the next stage of the request, which is going to be this function here. So I can actually attach this by just adding it here simply. So I don't have to rewrite this logic for both of these. So now if I say request dot to do, I can get the to do that we got here. And let's say I want to patch. So let me first do the delete over here. So let's say I want to delete a to do that I made. I can again say request dot to do. Request dot to do, and then simply I can say dot remove. Let me make sure that's correct. Find by ID. Yeah. I can just say to do to delete dot remove. Then this should be async. So again, I'll put this in a try catch in case any errors happen. Okay. So now let's try this. Back here, I'm going to add a request called delete to do. Then this is going to be a delete request to this endpoint. So let's say I send in some random ID like this. It says, so I made a delete request to this ID. So if I console log this, meaning I want to see why that error is happening, I can send this again, and it shows the to-do ID correctly. And let's see if I actually got the to-do. So I can come in here, console log this, send it again. Then it never reached this point. So let's see if I send a actual ID, if that will work. So I see an ID here. Okay, so now I got it. But it's not sending anything, which means I delete. It's because I never sent a response here. So I say response dot send status send order.json sh deleted to do. Okay, so now let me look at the ones I have. So I have two to-dos here. Let's say I want to delete this one. I can send it in here and it says deleted. Then when I get the to-dos again, only one to-do is left. So that's delete. Then there's also update. So for update, it's similar. I can just copy this. Update. Then again, this needs to be async. Then here, say update. So this is a patch request. So again, I can get the request body equals request dot body. So name and node is new data dot node. Then I can get the results of this. And I can send this again as JSON. So it's add a new request called update to do and make this a patch endpoint. Again, this is going to be JSON. So first I need to specify which to do. I want to update. So again, let's create one here. So I get the ID and I can put it here and send the new data. So name. So previously it was clean kitchen. So let's say I want to update to clean kitchen plus living room. And I'll keep the node the same. Okay, so now that updated. So it should have updated to clean kitchen plus living room. So let me name this list. Now you see it updated to what I want, but the node didn't update. Yeah, so this is a basic CRUD application, which means create, read, delete, update. So most applications like blog post applications, they all follow the same methods. So you would have a post method to create some resource, get method to list all of the resources, delete method to delete one of them, and so on. You can have a lot other stuff also. So now I'll show the database. Yeah, so you can see the database here. It has all of the things I just made. So if I make like something else, I can create it using this. Then it will show up in the database. And I can update it using this endpoint as long as I have the ID. So if I send the wrong ID over here, it will throw an error since it doesn't exist. So let's try and actually give a better error than this, because this is hard to understand what's happening. So in this, I will just say to do not found. So now if I send this worked, so if I send some random string here, it'll say to do not found. Okay, so let's list the to-dos again. I have 3. So let's say I want to update this one. Previously, this was do homework. So now I did, I'm going to change this to do physics homework. So I can send this. I got a response. And then you can see it says do physics homework and the database updated too. Yeah, so we built a basic CRUD application to do the basic tasks you might need for a REST API. Now, next thing would be to connect this to a front-end application, like using a front-end framework like React or something like that. And you can actually, then people can use it, because in this state, unless you know how to use the REST APIs, it's not very useful. So that's why you need a front-end application to actually make these usable to the end user. But yeah, I think that's it from me in terms of the coding side also. I'll open it up for any questions anyone has. I know I went a bit fast, but this is to show you like an introduction and how you can use this to build anything you want. But yeah, I'll open it up to any questions.
Yeah, guys, if you have any questions, you can either put it in the chat box or unmute yourself and ask as well.
Okay.
We have a question in the chat box. 1 second. Does JavaScript code read code from bottom to top when it runs, or it pulls requests from anywhere in the code?
Does it, so let me read it again. Does JavaScript read code top to bottom when it runs, or it pulls? So the way it works here in our, the way JavaScript works is it reads from top to bottom. So if I run this with the command, it's going to read all your code from top to bottom. But what it actually does is it registers these. It registers all these endpoints I defined. It registers them and gives them a function to run every time I make a request. So it's actually listening on all these. And whenever I make a request, it will run the function that I defined over here. So you can see I said app.listen. So I can even take this out and call this something else. So I can call this const delete to do equals, and I can actually put this here. So what this is telling is when this delete request comes in with this endpoint, first run this function. After this function is run this function. So the code actually gets executed top to bottom, but it just registers functions for any endpoints you have defined. Yeah, sorry. Let me know if I didn't answer your question well, or if you still.
Okay, I think that was clear. She said, okay, answered perfectly.
Okay, great.
If there's any other questions, you can also put. Do you use JavaScript or just Node?
So for our company, we use React.js with TypeScript, and we also use Node.js with TypeScript. So TypeScript is kind of an add-on to Node, since Node is inherently not type safe, which means let's say you have a very large application with a lot of data, you don't have type guarantees. So we use TypeScript because it helps us identify bugs earlier, and it gives all the variables we use types. So yeah, sorry, I went on a tangent about TypeScript, but to answer your question, yes, we use React for the front end and we use Node for the back end.
Any websites that we can learn syntax for Node from?
Yeah, so in college, we were not taught like web development, that sort of stuff. So most of the learning I did was from YouTube. So there are a lot, if you just search full stack application on YouTube, and you'll find hundreds of videos. Like any of the first 10 videos are very good, and they will probably explain it 10 times better than I did. But yeah, I think main resource is YouTube. You don't have to pay for any courses or anything. Everything's just there online. But yeah, I think main resource would be YouTube. At least for me, it worked.
Do we have any more questions? If not, yeah, if not, we can wrap up the session. Thank you very much, Mr. Sharith, for your time and on a Sunday. And thank you everyone for joining the session as well on a Sunday evening. This will be the last session for the Techathon sessions, and we will be coming up with new projects soon. Thank you for everyone that joined, and thank you, Sharith, for your time as well.
Thank you. It was great speaking.
And there's a lot of thank yous in the chat box as well.